This online lesson is about resolving equalities for a different variable. A lot of times in chemistry we'll get a formula, and the formula will be solved for a quantity like mass, but we might want something else like moles. So you have to be able to resolve an equation for a different variable, and at the end of this video you should be able to do that. We're going to start off by examining the idea that some things in math are opposites of each other. So, for example, take the operation 5 plus 2 equals 7. So if you look at this, you have an idea that if you take the number 5 and then you add 2, you will get 7. So there's an opposite to the operation of addition, and that opposite is subtraction. And so if I take 7 minus 2, that equals 5. So you'll notice that these two kind of processes are the exact same. They're just in the reverse order. And the reason why you can do them in the reverse order is because you're using operations that are opposites. See, look at 5 to 7, and then the reverse, 7 to 5. And the reason why these are both these are true mathematical statements is because addition and subtraction are opposites. So the first set of opposites are addition and subtraction, but there are other sets of opposites in math. So let's take the idea of 5 times 2, and that of course equals 10. And so that means that in order to find an opposite, we would have to basically say 10 something 2 equals 5. And you probably very clearly can see that what the opposite operation in this case is divide. So that means that multiplication and division are opposite operations. So later in this video when I'm talking about we have to do the opposite, that's exactly what I'm talking about. I'm talking about these kinds of things where there are opposites of each other. So let's apply this idea of opposites. Let's come up with a different idea that's more rooted in algebra. And that is, if you do the same thing to both sides of an equality on both sides of the equal sign, you haven't really changed the equality at all. So let's say I have, we'll just use all numbers first. We'll stick with 5. Keep it really simple. 5 times 2 equals 10. All equalities have two sides, and the sides are separated by the equal sign. So basically, when I say there's two sides, and I'll be saying that a lot in this video, there's a side over here. This is side, this is one side, and there's a side over here. This is the second side. And there's a rule in algebra that if you do the same thing mathematically to both sides of an equality, the equality will stay equal. So let's say what I want to do is I want to multiply by 2. If I multiply this first side by 2, then what I'd have is I would have 5. Let me erase that. Hold on one second. My line got away from me a little bit. So you would have 5 times 2, which is the original side, and then we're going to multiply that by 2, equals, and then we're going to do the same thing to the other side, 10 times 2. So before we had 5 times 2, which you very clearly know is 10, right? Equals 10. So that's very clearly an equality. So now let's look down here. We've multiplied both sides by 2. We took 5 times 2, we multiplied that by 2, so 5 times 2 times 2. And then over here we took the other side, 10, and we multiplied that by 2. So now let's look at what we have. 5 times 2 is 10, times 2 is 20. Right? And over here on this side, 10 times 2 is 20. So you can very easily see that this is a rule in algebra. If you do the same thing to both the sides of an equality, it will remain an equality, a true equality. So when we're doing things in algebra, you can do the same thing to both sides, and you won't change anything in the equation. So let's get a little bit more abstract here. Let's say I have the equality 2 times x, so 2x, plus 3 equals 13. So we have an algebraic equality here. You could call this an equation, 2x plus 3 equals 13. And as it sits right now, the equality, you would say, is solved for 13, right? We know that this side of the equation equals 13. And that's not really very useful because 13 is just 13. We know what that is. What would probably be more useful for us is if we solved this for x. If we resolve this equation for x, it basically tells us what number x should be in order for this to be a true equality. And so what's going to happen now is we're going to start using the idea of opposite operations and the fact that we can do the same thing to both sides of an equation to try to get x all by itself on one of the sides. So again, remember, the equal sign separates the sides of an equality. And there's two sides to this equality. And we want x to be all by itself on one side. So how are we going to do that? Well, we can do whatever we want to this equation as long as we do the same thing to both sides. And we know that there are certain operations that are opposite of each other. So here's how this works. Let's start with this plus 3 right here. You can see that the fact that there's a plus 3, that's something that's additional on this side of the equation that we want to get rid of so that x is by itself. So to get rid of it, whenever you want to move something to the other side of the equation, so we want to move this plus 3 over to the other side of the equation so that it's not over here with the x anymore. And anytime you want to do that, you have to use the opposite operation. So we can see that the 3 is being added, and the opposite of adding is subtracting, right? The opposite of adding is subtracting. We already looked at that. So what we're going to do is we're going to subtract 3 from this side of the equation. But we have to come back to this rule, right? Whenever you do something to one side of the equation, you have to do it to the other side so that the equality remains equal. So if we subtract 3 from this side, then we have to subtract 3 from this side. And so when we do that, plus 3 minus 3 is 0, so it basically disappears. So then you just have 2 times x. And over on the other side, 13 minus 3 is 10. That's still the same equality because we've done the same thing to both sides of the equation. And we picked subtracting 3 because it's the opposite of what's happening right here in this term. We're adding 3 in this term, so we're going to do the opposite to get rid of it. So we did the opposite of addition, which is subtraction, to both sides of the equation. So x is almost by itself now. There's only one other thing combined with it in this term, and that's times 2. So this is multiplication, and the opposite of multiplication is division. So another way to write division, other than using the actual division sign with the line and 2 dots, is to use a fraction. So if I do this, divided by 2, that's the opposite of multiplying by 2. And remember, by doing the opposite, you can move a term from one side to the other. So if I divide this side of the equation by 2, we have to divide this side by 2, right? And so what happens here is 2 divided by 2 becomes 1, which essentially means it disappears, it cancels out. And 10 divided by 2 becomes 5. And so you end up with x equals 5. And so what we've done is we started with this equality up here, and we basically resolved that equality for x. And now we know, instead of knowing that 2x plus 3 equals 13, now we know that x equals 5. And that's what we wanted to do. We wanted to resolve for x. So in chemistry, what's going to happen most often is you're going to have some kind of a formula. So let me give you an example of what I mean when I say some kind of a formula. In chemistry, we know that density we'll say D, density, equals the mass of an object divided by the volume of that object. So D equals m divided by v. Well, what if we don't want to calculate the density? What if we want to calculate the volume and we know the mass and density? Well, then we don't want an equation that solves for density. We want an equation that solves for volume. So we have to resolve this equation for volume, V. So how are we going to do that? Well, it's got to be all by itself on its own side of the equation. And right now, volume is on this side with mass. So we have to get volume over here, and then we can move the D over here with the mass, the density with the mass. So here's how this looks. The first thing we're going to do, right now mass is being divided by volume. So remember what the opposite of dividing? It's multiplying. So we have to multiply this side. I'm going to do all my new stuff in blue. Yeah, blue. So we have to multiply this side times volume. And what's the rule? If you multiply one side by volume, you have to multiply the other side by volume. And so what that gives me is it gives me density times volume equals mass. Now if we wanted mass, we could stop right there and we would have resolved it for mass. But in the example that I'm giving you right now, I said we actually wanted the volume, and volume's not by itself. So what's happening with this density term? We're multiplying it by volume. So the opposite of multiplying is dividing. So we're going to divide this side by density. And if we divide this side by density, we have to divide this side by density. Right? And so the densities cancel out. You get volume equals mass divided by density. And so you've resolved that equation for volume. So the only two things you really have to remember about resolving equations, really, is you have to know what the opposite operations are, and you have to remember that if you do an operation to one side of the equality, you have to do it to the other. Let's look at something a little bit more complicated. This is something that you're going to be encountering a little bit later in the course. It's a gas law, and it has 6 variables. So there's P1, which stands for pressure. There's V1, which stands for starting volume. And then there's T1, which stands for starting temperature. And that is equal to the ending pressure times the ending volume divided by the ending temperature. So you have this equality that you have set up here. What if I wanted to solve that for P1? Well, I would have a whole lot of oppositing to do. So the first thing I'd have to do if I want to solve for P1 to get it all by itself, I've got to get rid of the V1 and the T1 on that side. So the first thing I'm going to get rid of is the T1. And so to do that, I have to multiply by T1. And then those are going to cancel out on that side. But if I do it to the left side, I have to do it to the right side. So then I have P1 V1 equals P2 V2 T2 divided by T2. Whoops, I said T2. That's T1. So the only thing that's left now is the V1, and we're multiplying, so the opposite is dividing. So I'm going to divide this side by V1. And if I do that, I have to divide this side by V1. See, divided by V1. And so when you do that, the V1s cancel out, and you get P1 equals P2 V2 T1, all multiplied together, divided by T2, divided by V1. And you've solved that equation for P1. If you have any questions, as always, you can ask me anytime. Thanks for watching.